Hello everyone, this is Robin and welcome to my channel. Today I am going to discuss IoT based home automation system, how to make this system, how does it work, and I will discuss on how to code and install it. If you are familiar with this topic, then you can skip. Okay, now let's begin from what is IoT. IoT is an Internet of Things which can communicate from one machine to other with the help of internet and log the information of that machine, which send different information like moisture, pressure, speed, temperature, gaseous state, light, etc. That information is stored in the database, and in advanced IoT the data are fetched from the database and to the data analysis, machine learning, etc. So now move on Arduino. We all may see this board, right? Look, here is an 80 mega microcontroller, and Arduino is nothing but it is just a platform that decodes our code and stored in this microcontroller in binary form. And you can see here our input and output pin. We can use this pin for either input or output. Here you can see this two pin from last is transmission and receiver pin, and analog and digital pin are also here. Okay, now I'm moving on Wi-Fi module. This esp8266 or esp01 Wi-Fi module is one of the success Wi-Fi modules after esp32, and many people use this module for their project. It is very cheap and very much useful. Okay, this is a system on chip, that is SoC. Whole the Wi-Fi system is present in this chip. Here is the router, here is a client. You can either make this Wi-Fi module as a client or server. Through the help of this module, you can send GET request, PUT request, and we can also receive GET request. Okay, this is all about introduction. Now, we move on the working mechanism. I have made a vlog of my project on the Arduino website. You can get this link from the description. This is the picture taken in our exhibition. Here you can see the model of house. Inside this house there are 3 LED and 1 fan. We gave power supply from SMPS. Here is a relay module, SPDT switch and esp8266 Wi-Fi module. You can see the router here. We are using the router for local area network, and in the laptop the local server is running. And we are controlling the appliances from the mobile phone. Here is the UI of our application. Okay, now these are the components that we use in our project, and you can see here a circuit diagram. Here is a transmission, which is green wire in this diagram is connected to the pin number 2 of Arduino board. Receiver is connected to the port number 3, and this is the enable pin CSPD, and here is a VCC pin, and both are connected to the 3.3 volt of the Arduino board. For safe, you can use a voltage regulator of 3.3 volt for transmission, and the ground is connected to the ground of the Arduino. This LED in pin number 13 is for indicator. These 6, 7, 8, 9 are the pin connected to the relay module to enable the relay. These are an SPDT switch, and this is the power source. You can use either AC or DC according to the appliance's limitation, because relay and SPDT switch can handle up to 240 volt. Now this is our working mechanism. When the AC or DC power is supplied to the SPDT switch either turn on or turn off the current. The relay can handle the signal coming from the switch, and relay can be controlled from the mobile phone. So you can control appliances either from the physical switch or from the mobile phone. If the appliances are turned on or off, we change the voltage to 5 volts and the signal is given to the Arduino. Arduino sends the command to the Wi-Fi module, and this module sends the GET request to the server through the router and stored in the database. We can see that data from the client. This way, the present status of the appliances can send to the server, so that we can see the status of the appliances remotely. Now move on the source code. It is very easy to understand. This is a file of Arduino code. I include the software serial.h header file. This is used to represent a pin for serial communication. We initialize the port number 2 and 3 for receiver and transmitter. These 6, 7, 8, 9 are the output pins. Pin number 13 is for indicator. Here you can see these pins are initialized as an output. Initially the pins are in high voltage. Now inside the loop, the signal or message in the serial pin 2 and 3 is checked. If the message in the esp8266 object is available, then the code inside this block is executed. In that message, if it finds the plus IPTT character, the code inside this block is executed. Then it stores the connection ID. Here we are subtracting 48 because the characters 0 and 1 correspond to the 48 and 49 in ASCII. Similarly, it stores the pin, and here you see the send data function. Here is the initialization of Wi-Fi module for the first time before going inside the loop function. First, we restart the Wi-Fi module, then we change the working mode of the module to 1. Here 1 means it works as a client. And then after we join the access point of our router, you have to put your SSID and password of your Wi-Fi. Then after we log the IP address of the ESP module. I will provide you tutorial of how to change the dynamic IP address of the machine in my next video. You can go to that video by clicking on the bottom above or from the description. Then we change the multiple connections and we connect to the server in port number 80. Okay, now move in the control.html. Here you find on or off button. We use ID with number that is 60. Class name, get ID. If this button is clicked, then the send request function is called with parameter 60. In script.js, you can see the send request function with ID argument. This is all the part of UI, okay? When you click on the button, it changes the color of the button from primary to warning. Then after, it changes the button from enabling to disable. Here we create a new object called xHTTP, and then it opens the get request with the IP address of Wi-Fi module. You can change this IP address of your Wi-Fi module by logging in the serial monitor in Arduino, and this 80 is the port of Wi-Fi module. Here pin is the parameter or key passes to the module along with IP address. We are sending the bottom ID. Here true is there because it is asynchronous. Then after it sends the request to that address and port. Here the timeout function is used because the action in the hardware took some time after sending the request. Here it changed the color of the bottom from warning to primary and enable all the bottom. This all happened after 400 milliseconds. Here you see the main logic. If the ID is even, that is if ID of the bottom is 60, 70, 80, 90, then we add +1 and make it an odd number. It off the appliances of the modem. Similarly, if the ID is odd, that is if ID of the bottom is 61, 71, 81 or 91, then it subtracts -1 and make it even number again, and the signal of the appliances will be on.